Lesson 7-3, Rational Exponents. The objective is to evaluate and rewrite expressions involving rational exponents and to solve equations involving expressions with rational exponents. So pretty much I guess we need to decide what rational exponents are. And rational exponents, basically like rational numbers. Anything that can be written as a fraction. Hopefully you remember rational numbers in the definition. Anything that can be written as a fraction. And rational exponents are fractional exponents. Where do they come from? They come from the radical sign. This is the radical sign. Let me get that off of there. This is the radical sign. Alright, and what the radical sign means is you're taking whatever's inside of it to a root. If you just have radical A, it's automatically a square root, and that's the most common one. And what that means is A to the 1/2 power. So square rooting and 1/2 power both mean the same thing. It's saying what number times itself gives me A. That's what a square root is. If you would do square root of 9, we all know that's 3 because 3 times 3 is 9. So we're looking at roots. You just now have to be introduced to more than just a square root or a power of 1/2. So this is called a cube root. What times itself 3 times gives me A. It's the same as A to the 1/3 power. Or fourth root. What times itself 4 times gives us A. It's A to the 1/4. Now something that's really, really important to know. If you have an equation where the bases are the same and they are two powers. So if A to the x equals A to the y, the bases are same A, then x equals y automatically. So you're going to have to be figuring some of those out as well. Now, the thing is, they're not going to be that cut and dry. They're not going to give you A and A. You're going to have to maybe manipulate it a little bit to get it the bases the same. So here's an example of that. It says that 6 to the x power equals 216. Well, it just so happens that 216 equals 6 to the 3rd power. So you would have to take and figure out that, so practicing or working on it with your calculator to find out what that is. And it turns out that then 6 to the x power equals 6 to the 3rd power. So you could conclude that x equals 3. We're going to have some more of that in your assignment and in examples. What?
Couldn't you just look at the bottom example and said that x equals 3?
You weren't given this.
Oh.
You weren't given that. You were just given that problem right there. Okay? You had to figure out that 6 to the 3rd power. You're given just that. You'll see in just a minute, okay? I think you'll see more in just a minute. All right, so let's check out some examples and what kinds of things you're going to do with this. So we're going to start off with something just basic here. Write radicals in exponential form or exponents in radical form. So basically this is just rewriting, okay? This is just rewriting. We're not calculating anything. We're just practicing taking it back and forth so that we know what they mean. So if it says 81 to the 1/2 power, we need to write that in radical form. That means we need the square root sign in it. My tree, what would that be? Square root of 81. We're just rewriting them just to show that we can learn the difference between exponential form. This one was exponential. It's to an exponent. This one's called radical form because it has a radical in it. Okay? So the next one is radical 38. And that means we need to take that one and put it in exponential form. So 38 would be to what power? The half power. When there's no number there, you're assuming it's a square root. Okay, let me add a little bit more to it. So 12 times m to the 1/2. It's in an exponential form, so we need to put that in radical form. And you would just, the only thing to the 1/2 is what? M. So you don't put the 12 in the radical, it's just 12 in front times square root of m. 12 times the square root of m. Alright, now just the flip side of that, I've got 32 times the square root of w. So that's in radical form. I need it in exponential form. So I would put 32 and write w to what power? 1/2. When there's no parentheses involved or anything, then that means just the base that the exponent's written on is the only thing to that power. Now this next one shows you the difference between D and E. Okay? The next one has the 32 inside the radical. So the 32 is also to that power. So in that particular case, you would have to use parentheses 32w to the 1/2 power. Do you see the difference between D and E? Okay, anybody have questions on that? All right, Ben. Write it individually? You could, but I wouldn't. The question was, could you do 32 to the 1/2 and W 1/2? Sure, you could, but you don't have to. All right, questions there. That's just practicing writing back and forth, so you'll have a little bit of that. Now let's talk about actually maybe evaluating a little bit. Okay, evaluating it a little bit. So now let's see what happens when that rational exponent isn't just a 1 over something. Let's say it gets a little trickier. So a to the m over n. All right, a to the m over n. So what happens here is the n, the number in the denominator, like the examples above, that's the root that you go to. Okay, if there was a 2 down there, it was a square root. If there was a 3 down there, it was a cube root, and so on. But now there's a number on the top that's not m. Well, that's what power you take a to. So this is defined this way. A to the m over n power would be the nth root, so the little n goes in here, the nth root of a to the m power. So basically 32 to the 2/5 power, you'd have to put the 5th root there with the radical sign, and then 32 squared. Okay, that is 4 when you evaluate it. So you can evaluate that lots of different ways. Let me explain. So if you are doing 32 to the 5th root, well, if I can get this right, that's 2. But I have to square it because that's still inside, which makes it 4. Okay? You could do this with your calculator. I showed you, remember y to the x and all that the other day? You can use that to do these. After a while, you kind of get the hang of it because they're going to become common. 2 to so many, whatever power becomes pretty common. 3 to a power becomes common. 4, 5, 6, just a few of them. They become very common, and you'll get used to that the more you do of these. So you could go either way. Yes.
How do we get the exponent?
You're going to use the rational part. You're going to say to the 2/5. That's how. Or 1/5 if it's just a 1/5. All right. So, yeah. No. You could use your calculator and do the power. You would do this. You would do 32. Actually, let me do it this way. You would do 32, that caret, and then in parentheses do 2/5 like that, and that should give it to you. Okay? Or y to the x, you could do it that way. Actually, you probably have some of you probably have a button that looks like this also. It is a radical sign with a variable in there, and that would be any root. Okay? Some of your calculators probably have that. All right, let's try this one. This one should be pretty easy for us to do maybe without a calculator. It is the square root of 81 to the 5th power. Well, just for the sake of rewriting it, what would that be with the rational exponent? 81 to which power? 5/2. But yes, because the number inside is the numerator and the number outside is the denominator. What is the square root of 81? We all know that. 9. And then we have to take 9 to what power? 5th. And that gets huge. Yeah. That one would be 59,049. So 81 to the 5/2 power, 5/2 power, and the square root of 81 is 9 to the 5th power, 59,049. Okay, questions about that? Zach? Huh? I'm just showing you how to rewrite it if you had to, 5/2. The 2 is where you do the square root, and the 5 is what power it goes to. That's what happens to the 5/2. Okay? You don't have to rewrite this like that. I'm just showing you for practice when you have to. All right, let's look at some of these that you have to solve these equations on. Okay? So this might help you understand a little bit better. We've got example G, H. Oh, we got a few. Okay, so example G, 9 to the x equals 729. So what I would definitely do is take 9, you know it's not 9 squared. I'd take 9 cubed and then do it until it either is 729 or it goes higher, because then we could always take 9 down a little bit, and I'll show you what that means in just a second. Is 9 some kind of a root of 729?
Yes. It was cubed.
It was cubed. Okay. So then you're going to take this and you're going to rewrite it like this. You're going to say 9 to the x equals 9 to the 3rd. And seriously, once you get the bases the same, you just say then x equals 3 and you're done. Okay, now 27 to the x and 3. All right, well, 3 is got to stay 3. And we all know 3 is to the 1st power. 27, however, what power is that? Huh? It's to the x, but 27, can we break it down to a 3? 3 to the what power? 3 to the 3rd. So, hang on just a minute. We'll finish this one. 3 to the 3rd to the x. And just like power on a power, that's really 3 to the 3x power. Okay? 27 is the same as 3 to the 3rd. And you got to multiply these like that. Well, now my equation is 3x equals 1. Do you get that? And divide by 3. So x equals 1/3. It's because this base and this base, we got them both the same. So then you just kind of get rid of those and you say 3x equals 1, so x is 1/3. Please do not change that to a decimal.